Good afternoon, distinguished colleagues and guests. Let me consider open the meeting of the Dissertation Council on the defense of Mr. Demchev for the defense of the candidate degree of Physical and Mathematical Sciences on specialty 250028 archaeology on the topic the methods of retrieval, analyzing and monitoring the drifts of sea ice and icebergs based on satellite radar data. Consider open according to the order of St. Petersburg State University number 3811/1 from the 12th of April 2019. Ms. Zakharchuk Evgeny Alexandrovich, Doctor of Geographical Sciences, Professor, acting head of the Department of Archaeology of St. Petersburg State University, was appointed the chairman of this Thesis Council. And allow me to introduce my fellow board members. Tatiana Belodinka, Doctor of Geography, Professor of the Department of Archaeology of St. Petersburg State University. Leonid Timokhov, Doctor of Physical and Mathematical Sciences, leading scientific worker, Professor of the Department of Archaeology of the Arctic and Antarctic Scientific Institute. Matti Johan Lapiranta, Doctor of Physical and Mathematical Sciences, an honored professor of the University of Helsinki, Finland. According to the federal law of the 23rd of August 1996, number 127, Federal Law on Science and the State Scientific and Technical Policy, St. Petersburg State University has the right to independently award academic degrees. The corresponding order on the procedure of awarding academic degrees at St. Petersburg State University, on the basis of which we conduct our meeting of the Council, was issued on the 1st of September 2016, number 6821/1. In accordance with this order, the meeting of the Dissertation Council is considered eligible if at least 2/3 of the approved membership of the Dissertational Council takes part in its work, but not less than 4 persons. There are 6 members in our Dissertational Council. 4 of them are present, thus there is quorum. And the procedure of today's meeting, with a total duration of no more than 2 hours, is the following. The first, the chairman's summary report on the main content of the documents submitted by the candidates and their compliance with the established requirements. Answers to possible questions, 5 minutes. The brief report of the candidate for the degree reflecting the main points of his research. The questions to the candidate, strictly according to his report, no more than 2 minutes for one question. Responses of the candidate. Number 4, the speeches of all the members of the Thesis Council by turns, with reviews, with a statement of their positions, with questions and suggestions to the candidate. No more than 5 minutes for each review and no more than 5 minutes for each answer of the candidate. As all the reviews were placed at the website of St. Petersburg State University, dear board members, please announce only your remarks and conclusions. Number 5, an open discussion. Speeches at the request of those present at the defense of the thesis of persons, with a brief presentation of their positions and with specific questions and proposals to the candidate, strictly on the topic of the research, no more than 5 minutes for each applicant. Number 6, final answers of the applicant for the questions asked, no more than 5 minutes. The speech of the scientific supervisor, no more than 5 minutes. 8, a chairman's summary report and other board members. Number 9, an open individual voting, counting of votes by the chairman of the Dissertational Council, with entering the results in the minutes of the meeting, 5 minutes. Number 10, decision on awarding or not awarding the academic degree of St. Petersburg State University. Number 11, the final words of the applicant, no more than 2 minutes. Before switching to the realization of the meeting's rules of the procedure, I remind you to switch off your mobile phones. Thank you. I also inform you that an audio and video recording of our meeting is being conducted, as well as a live broadcast on the website of St. Petersburg State University, and simultaneous interpretation of speeches from Russian into English or from English into Russian is also provided. And Chairman's summary report about the main content of the document submitted by the candidate. The dissertation of Demchev for the seeking of the degree of Physical and Mathematical Sciences, Archaeology, on the topic methods of retrieval, analysis and monitoring of the drift of sea ice and icebergs based on the satellite radar data, was accepted for the defense on the 8th of April 2018, number 3188/1. The candidate submitted the following documents to the Scientific Secretary. An application form addressed to the Rector of St. Petersburg State University, Mr. Kropachev, about the acceptance for the consideration and defense of the thesis submitted on the 29th of November 2019. The copy of the document about higher education, the document certifying the successful passing of candidate exams, the review of the scientific supervisor, Mr. Makstas, the leading scientific worker of the Arctic and Antarctic Research Institute, a list of publications consisting from 6 works, including 2 articles in peer-reviewed journals. 4 articles are in Scopus and Web of Science. Dissertation is submitted in Russian and English, both in paper-based version as a manuscript and in the electronic form. All the listed documents comply with paragraph 12 of section 3, the procedure for awarding academic degrees at St. Petersburg State University. Application number 1 to the owner. Dear board members, do you have any questions concerning the documents? And now, the next point of our agenda, brief report of the candidate, no more than 20 minutes. Denis Mikhailovich, the floor is yours. Good afternoon, distinguished members of the Dissertation Council, dear colleagues and friends. My report on the thesis, which was done at the Scientific Center, Arctic and Antarctic Scientific University, and in Nansen's Center under the supervision of the Doctor of Physical and Mathematical Sciences, Makstas. The relevance of the work is due to the growing pace of the development of the Arctic territories and the use of sea routes that run through the waters of the Arctic Ocean and associated needs to develop and improve ice monitoring methods. In particular, to increase the informativeness of the results of processing remote sensing data, verification of the description of the ice cover dynamics in numerical models in order to improve the quality of ice forecasts, to improve the quality of ice cover images from radar data, which is associated with the development of effective speckle suppression methods, to improve the accuracy of determining ice drift. Very often it has very critical significance. Thus, the relevance of the work is due to the need to increase the information content accuracy and integration of data on the ice drift. The aim of the thesis is to study, create, and evaluate the effectiveness of methods for the restoration, analysis, and monitoring of ice drift and icebergs based on adaptive processing of radar images in the framework of the ice management task. To suppress noise-like manifestations that impede the visual and automated analysis of X-ray images of ice, the proposed model based on the smoothing of images proposed by Perona and Malik solutions of diffusion equation from physics in application to the image. The equation is written for the local intensity in divergent form and is expressed in terms of the conductivity function and the local brightness gradient. This approach allows you to control the amount and the direction of smoothing in a certain way. Perona and Malik proposed two parabolic functions of conductivity which allow to adjust the degree of blurring based on the analysis of the local structure of the image through lambda coefficient, which regulates the application of diffusion. In the course of experimental calculations, the most effective of them for sea ice images, G2, was determined, and a scheme for calculating the contrast ratio was chosen. And we chose the 6th percentile of the histogram of a smoothed version of the image. To check the filtration efficiency, a series of experimental calculations was performed on satellites SAR images of ice containing its characteristic features: spawning, cracks, hummocks, ice ages. The comparison was carried out with linear Gauss filter. For all cases, the use of an adapted PM model made it possible to preserve useful features in the images and smooth out noises. It is also important to note that the preservation of correct coordinates, contours, when using a linear Gaussian filter, undesirable transformations were observed, causing blurring of the object boundaries. Thus, provision number 1 for defense is the rationale for choosing the anisotropic diffusion method for suppressing speckle on SAR images of ice. To assess the effectiveness of modern methods of tracking local features in the annex to the radar images of sea ice, a typical flow chart was created, which includes three stages. At the first stage of the detection, characteristic points were determined. At the description stage, descriptors are complied that allow to formalize the description of the neighborhood or detected point. And the descriptors are mapped using various similarity metrics. As a comparison algorithm, two widely used methods were chosen: SIFT and ORB. The first of them, it is a standard in the sphere of computing vision. ORB, it is its alternative. It is more computationally effective, and the methods on the basis of nonlinear diffusion, MAKs, was used. The experiments were used for the different seas of the Arctic Ocean. As a result, the proposed approach to the processing of SAR images of sea ice based on filtration using nonlinear diffusion allowed us to obtain the most informative results in restoring ice drift. And thus, this approach to the processes of SAR images of sea ice based on filtration using nonlinear diffusion allowed us to obtain the most informative results in restoring ice drift in the regions of the Central Arctic, as I have already mentioned. Provision number 2 for the defense: an assessment of the application of methods for tracking local features of SAR images for monitoring ice drift. The paper proposed an algorithm for the recovery of ice drift, which was created on the basis of the original combination of detector plus descriptor adapted to SAR images of ice. The model is based on a multi-scale image representation, determining local maxima at their levels through the calculation of Hess matrices and their approximation using SHA filter. To achieve rotational invariance, the general direction of the orientation of the neighborhood of the singular point is found. Derivatives for each partitioning area are summed into a vector descriptor, which is normalized to a 64-bit vector to relative units to achieve invariance to image contrasts. We used gas matrices on the basis of detecting. It allows to economize of the calculations at all. On general, the next slide shows the block diagram of the proposed algorithm, which is the result of the preliminary studies of the application of the nonlinear diffusion methods for SAR images of ice. The output of the algorithm is the fields of the ice movement vectors and the calculated values of the moduli and directions of velocity of the drift. The third provision for the defense: the original algorithm for recovering ice drift fields. To analyze the ice drift fields obtained by reconstructing from successive satellite images, the application of the vector algebraic method was proposed, in particular by the values of variant I1, the zones of greatest intensity of ice drift variability, which are located in the northern part of the Barents Sea, in the area of Beaufort Sea, on the periphery of the Arctic anticyclone, were identified. According to the analysis of the multi-year data series for 1979-2006, drift velocity trends were obtained. The span, as you may see, more than 25 years. On the basis of the invariance of the tensor correlations between vector processes can be established. The paper demonstrates the solution of the problem of determining the form of the relationship between the ice drift fields obtained from satellite-based information and model data by calculating the correlation indicator and the correlation indicators, collinear and orthogonal. The interrelation can be established within the framework of consideration of a single physical process without breaking within the considered single characteristic, the direction of movement of the ice. For approbation and practical application of the proposed algorithm for the recovery of drift fields, we chose the northern part of the Ob Bay. It is of high attention today because it is the most prospective from the point of view of hydrometeorological provision is in our Arctic seas. Thus, we developed operational algorithm and we applied it for the ice season 2016-2017. Based on the recovered movements of the ice, drift velocities were calculated and then ice divergence for the diagnosis of the processes of thinning and consolidation. The velocity of divergence of ice were calculated to diagnose the process of the scattering and joining of the ice. As a result, for the first time, for the northern parts of the Ob Bay area, histograms of the values of the modulus of the average and maximum ice drift velocity were constructed on a semi-daily interval. The ice drift rose. It was also found out that the occurrence of compression zones perpendicular to the navigable canal is typical for the navigation area. Thus, provision number 4 for the defense, quantitative estimates of the drift velocity fields and ice deformation obtained for the northern part of the Ob Bay for the first time. Within the framework of this study, the task of monitoring the iceberg threat was also solved. The iceberg drift model was improved, increasing the spatial resolution for the seas of the Western Arctic. The results for the iceberg model were used as an input calculations on an adaptive version of the regional atmospheric model near surface wind and temperature fields, and the numerical model of the ocean currents on the 33 horizons. Verification was performed using data from buoy observations in the parts of the Kara Sea. Using the model of the developed technology, the inverse problem was solved with the ranking of icebergs by their weights. They were found out in the region of Stockman deposit in 2014, and physical information ensuring the safety of navigation in the ice. In 2019, a patent was obtained for the creating the ice monitoring system, which as one of the main blocks includes the implementation of the proposed algorithm. Number 2, the use of the vector algebraic method for the analysis of ice drift fields, including the validation calculations and obtaining regime information. Unlike a component method, it allows to conduct analysis of the ranges and fields of ice drift. Number 3, technology for predicting iceberg drift, which is based on a numerical model. The operational use for the production of short-term forecasts during the hydrometeorological support of exploration drilling at the Universitetska 1 base in the Kara Sea in 2014 confirmed the effectiveness of the proposed solution. The experience can be used to create an integrated automatic ice monitoring system. As a part of this work, a wide range of research and practical problems was solved related to the improvement of existing and the search for new solutions for the development of the ice radar monitoring, and as a goal to increase its effectiveness. In this case, emphasis was placed on the possibility of practical use of the developed or improved methods, technologies, as well as data obtained of the basis of the application. Thus, it is possible to formulate the following single conclusion on the work in question. In this study, approaches to restoring, analyzing, and monitoring ice drifts and icebergs were proposed, improved, and implemented. The effectiveness was evaluated in the framework of raising the information content, quality, and integration of ice monitoring methods in the Arctic. According to the results of the research, 8 publications appeared. 6 of them are journals recommended by High Attestation Commission of the Russian Federation. One of them in Scopus and Web of Science. Also reports were made, and 28 conferences, international meetings, and symposia. That's all for now. Thank you very much. Do you have any questions from board members to Denis Mikhailovich? If you have any questions to Denis Mikhailovich, don't hesitate to ask him. Denis Mikhailovich, tell us, please, you mentioned nonlinear and mesotropous diffusions. Are they different from each other, or it is the same? In fact, they are different, but I use them as the same thing. Anisotropy involves the extent of the application of the diffusion, but strictly speaking, anisotropy involves not only the extent of blurring, but also the direction. Prawn and Malik, their model is called anisotropy model, but nevertheless there are some discussable moments. You used Viviet higher, and instead of Viviet of higher, then you use the matrices of Gesser. Am I right? Viviet higher creates the basis. Hesse matrices, do they create basis? Yes, you are right. The idea was that they use at the detection stage and also at the description stage. Initially, they are calculated for the detecting stage, and then they are used in the description process. And the last simple question: which prospects in the practical application, forecasts maybe, or the first prospect is assimilation into numerical models of the drift data and more precise evaluation. As the algorithm is more precise, this advantage will allow us to evaluate the ice, the rheology of the ice, the assimilation of the data required. Thank you. Any other questions? I have a question concerning the following fact. You consider the methods of restoring or retrieving the ice drift with the help of radar images. to which extent it is the continuation of the method of the retrieval of the ice drifts in optical images, or it is principally different methods. In theory, we did not conduct such experiments, but in theory, the situation with optical data is rather easier. If we take cloud situation with clouds, there is no problem of the specular noise. And in optics, there is no such effect, but there is another drawback. But it is a successful direction in terms of the application of the algorithm and the complexing of the various sources of data. It will be the continuation of such works connected with practical application. It seemed to me that the second and third chapters, they are organically interrelated, connected, but you separated them. Vector and algebraic method, it is a continuation of the retrieval of the ice drifts with the help of radar data. Why did you divide them? According to the volume, or are there any other reasons for that? In the second chapter, I solved the problem of retrieval of the data, and in the third chapter, I tried to analyze this retrieved data. The second chapter is dedicated to the data retrieval, and the third chapter is devoted to the analysis of this data. Of course, it can be considered in one chapter, but I decided to separate this into two chapters: the retrieval of the data and then the analysis of this data. And the last question concerning monitoring. The Institute of the Arctic issues reviews which characterize the state of the ice cover, and the vectors are shown there, are introduced there, but it seems to me that for the characteristics of dynamic condition of ice cover, the spectrum of parameters you analyzed, you reviewed, could be expanded. Rotor divergence, they help to look from a different angle at the dynamics of ice cover. Are you going to implement this monitoring into the reviews? Of course, I am planning to do it, and it is very useful from the scientific and practical point of views. And of course, such data should be taken into account in the reviews in order to receive regime information, diagnostic information for previous seasons, decades, and so on. And one more question. The last question from this cycle: can it exist, especially in winter? The processes of pressure compression are very important, and using radar images, is it possible to receive the information about the deformation of ice cover, the change of the thickness of the ice, and so on? Potentially, such works, such studies can be conducted, and I even saw some literature sources when the calculation on the basis of the analysis of deformation characteristics, the thickness of rampant ice were shown, but it is the task of a separate research, and it can become the logical continuation which was offered in my work. Thank you. Matthew, do you have any questions?
The first question is
Первый вопрос о вращении ледяных потоков для определения отдельных потоков.
scale. I saw you analyze the strain rate, but not the rotation.
Exactly. I analyzed only.
Я проанализировал только дивергентность, отклонение. Мы не...
Curl. So only divergency have been considered yet, and we should go there, no doubt. And yeah, because the full deformation also should include not just shear plus divergency and also rotation.
Does the method allow you to separate?
Yeah, sure.
Okay.
Yeah, but in this task we have been focused on identifying of zones with convergency mainly to analyze that.
Yeah, the second question is about the drift. So how would you say, what is the difference of the drift of icebergs and sea ice?
Because icebergs driven mainly by currents. This is the main difference, because sea ice is mainly driven by surface currents or wind, but icebergs mainly driven by currents on different levels. So it could move opposite to sea ice.
Yeah, in the iceberg model, you modeled the force between iceberg and sea ice as a quadratic. So is there a scientific basis for this quadratic form?
Yes, but it's only free drift. Our model was tuned on iceberg in open water, only not in sea ice.
Okay, I see. And so the next question is then about the ice velocity distributions in the Ob Bay. The first class you had from 0 to somewhere 0.1 knots or something. Yes, so did you consider separately the velocities which are beyond the within the accuracy of the method? So it would need to be taking exactly 0.
Yes, I agree on that. We filtered out ice speeds less than some value, but I don't remember which value we.
Yeah, this class category of apparently non-moving ice would also be quite interesting to see.
I agree.
In your histograms.
Could be biased data.
And the last question is the operational sea ice model, operational iceberg model. So you have the drag force between the drag coefficient of the water and iceberg. Is that a fixed constant in the model?
Yes, it's fixed and constant, no deterioration included in the model.
Yeah, actually, when you are observing the iceberg several times, you could make a correct forecasting and update the drag coefficients every time, because it's very difficult to know how large it is.
Yes.
And did you consider this alternative?
No.
Okay, so maybe that is a future question.
It could be future
thank you.
Of the model.
And this was my last, Mr. Chairman.
Thank you.
Thank you, Matti. У меня тоже несколько вопросов. Вот хорошо известно, что Северный Ледовитый океан и его арктические моря – это
The Arctic Ocean and Sea Ocean, these regions with current dynamics, with tidal dynamics, is it enough to have to obtain the data from radars once a day in order to exclude tidal aliasing in these territories? First of all, it depends on the zone, which is considered in the Central Arctic. It's not actual, but in other seas, it's quite influential, but it was not the task of the thesis. But it is very important to do in order to understand which data we are obtaining. Have you ever thought about the fact how to solve this problem with such a discretion from the satellite data? We don't have such a solution. And one more question. What will be more successful in the future? Satellite radar methods of the exploration of ice drift, or computational numerical hydraulic modeling? Or these two methods should coexist in the future, or only one method will exist? In my mind, to my mind, numerical hydraulic modeling will be prosperous in the near future. Numerical modeling and distant sensing, it will exist as an assistant. And the receiving of satellite data and numerical hydraulic models, these are the future. Thank you very much. Any questions? Any other questions? No questions. Denis, thank you very much. And now the announcement of the reviews. There is no voice in the microphone. There is no voice in the microphone, unfortunately. The interpretation is impossible. The anisotropy of Blorentz application depends on the local structure of the image. If we have the ice age or some other object, if there is such an object, we don't have to blur it because there are some peculiarities, and when there is a dispersion of the singular, the blurring procedure is applied. No voice in the microphone from the person who is asking the question.
Ну вот метод прослеживания локальных особенностей.
The method of tracing of local peculiarities. There are some cross. And as for the problems which will help to solve tasks which will help to solve retrieval problem. Speckle sound, speckle noise. It is a distortion in the form of the noise. It is the multiplication noise. And when you analyzed this task, which criteria of quality did you use? What did you use as a limits? No model of noise. I used these images of synthesized aperture. They involve the shooting of the same areas for several times, and multi-locking of these shootings. This effect is removed, is decreasing. Ready image, we used only ready image. The speckle model, and your own method of filtering, do you compare it only with Gauss filtering? Why? Because the nature of the refracting of this signal is of a diffusion character, and this method is based on diffusion, and this idea helped us to develop this direction. And special points, specific points, how did you define them, and how did you evaluate the increased informativity? And as for the specific points, these are extremums, local maximums, where gradients are very strong, and these are points which a priori can be more successfully traced, monitored, and informativeness was evaluating due to the density of the fields, the distance between initial points of the vector of the drifts. Dear colleague, please introduce yourself. It is according to our agenda. St. Petersburg Electrical and Technical University, the Department of Television. I have two questions. Please, Oleg Polomeyev, Arctic, the Institute of Arctics and Antarctics, the head of the Department of Satellite Information. The first question, to identify iceberg and ice drifts, which polarization did you use, HH, HV, VV, or some other polarization? Traditionally, I used HH, HV polarization, and there is no direct answer which is better. It depends on the meteorological conditions. Moreover, it is accepted that HV is more acceptable, but in case with Ob Bay, HH was more successful. Horizontal, the transmission of radio wave in vertical and horizontal positions. The second question concerning icebergs. We speak about icebergs with sizes more than 100 meters. You know that growlers, they are more dangerous with the length of, with the size of 15-20 meters. How can we identify such icebergs? It is important for Arctics and Antarctics, where wind overloads, currents exist. There is a lot of dynamics. How do you offer to solve the problems of the movement of such dangerous phenomena? It is a very complicated problem, and no existing model of the drift of such growlers is successful. We observed such icebergs. They can be overtaken by the wave, and such models, as for the literature review, there are no such models, but it is a task which has to be solved. and it is the most dangerous objects which really threaten the vessels and engineering constructions. And the third question, to support Denis, the problem of monitoring, which how often can such icebergs be monitored? It is a problem of Roscosmos, Russian Space Institute, and I think that it is our problem, and we should pose such questions. Thank you. Any other questions from the hall? And those who asked questions, please enter your name into the registration form. And now, a moment, please. The announcement of the reviews of the chairman and other members of the dissertational council. All in all, we have got 5 reviews. There are no external reviews. Out of 5 reviews, all of them are positive. All the reviews were placed at the official website of St. Petersburg State University. I kindly ask the board members not to read out your reviews. Please focus on the questions, remarks, and conclusions. And now I want to give the floor to the board member Belanenko Tatiana Vasilievna, the Doctor of Geographical Sciences, Professor, the Department of Ocean Studies of St. Petersburg State University. I have got all remarks, and all of them are long. There are no cases when the algorithm of ice movement can have limited application. It is based on the analysis of gradient information, which is not always typical for SAR images of ice cover. As experimental calculations show, areas with a predominance of perennial ices and smokes, frame strait polar regions, or areas with a high intensity of dynamics, for example, Ob Bay, are characterized by differences in brightness in zones of splits, cracks, ice ages. Hummocks are considered. For cases of even annual ice, approaches based on the use of brightness gradients may potentially have limited application in comparison with the traditional cross-coloration method, which operates with normalized brightness values for image blocks. Question 2. From the description of the ice drift algorithm in Chapter 2, it is not clear why the case algorithm descriptor has been replaced by a modification of the case descriptor. From the further description, the author makes a conclusion about the lack of accuracy of the binary descriptor using the ORB as an example, but there is no similar additional justification for a case. Number 3. Chapter 3 represents the results of a climatic analysis of the series and fields of ice drift up to 2006, which reduces the relevance of the findings. Another disadvantages include the lack of comparison with the conclusion about the trends of ice drift velocities obtained in the works of other authors. From Chapter 4, the author's contribution to the development of iceberg drift monitoring technology in terms of their detection using high-resolution SAR data is not obvious. There is also no indication on how this data is consistent with the confirmed actual position of icebergs that are detected. Tatiana Vasilievna, thank you very much. Denis Mikhailovich, please, your answers. As for the first question, concerning the application of drift algorithm, I studied the areas with intensive gradients, and due to the morphology of ice coveraging in those areas, some problems can appear in those areas with the application of this method. The solution of such a problem may be a logical continuation of the study of the applicability of the proposed algorithm in different seasonal and geographical conditions of the freezing seas. Maybe traditional cross-correlational methods should be applied there. As the second question, the author missed the rationale for using the case descriptor as the basic of the algorithm being developed. A case descriptor was created to simplify calculations for use in near real-time mode, and since there is no such critical requirement in the task of restoring ice drift, the choice was made in favor of using and adapting a more computationally extensive but more reliable and accurate approach. As for the analysis of the series and fields of ice drift up to 2006, we have the task of the application of vector algebra method to the ice drift. About the author's contribution to the development of iceberg drift monitoring technology in terms of the detection using high-resolution SAR data. There is no my own contributions. It is the contribution is connected with numerical modeling and that's all. Tatiana Vasilievna, are you satisfied with the answers of our candidate? Yes, I am satisfied and the answers are proper. And now I would like to give the floor to the board member, Matti Juhani Leparant, the Doctor of Physical and Mathematical Sciences, the prominent professor, honored professor of Helsinki University.
Okay, so for your presentation and the thesis, I was pleased to read it, and I was, from the point of view developments in the sea iceberg research, I was picking up 2 points. So the algorithm you have developed, so this seems to overcome the earlier approaches, and this will lead us for new information in ice kinematics and understanding the sea ice dynamics. You mentioned or wrote very strongly about practical applications, but it also we have this basic research part, so that further understanding of the ice kinematics from this data would be important for the future. And you mentioned also this is useful in modeling, and I was really missing about what kind of features we can obtain from modeling, especially for the rheology of the ice from the processing of the data. So considering the SAR as a remote sensing tool for sea ice, what the best we can get from the SAR is with automated algorithms. This is the kinematics, and so in this sense, the focus in the work is good. If we are looking for ice types or any properties of the ice other than kinematics, we have a lot of problems in the interpretation, because the mapping between the sea ice and SAR is not one-to-one. But kinematics, this gives us the real good data, so there is not much to question about are the velocities correct or not. They are correct up to the resolution provided by the satellites. With Iceberg, when you go down into scale, then there is a very serious question, which also was brought up today, that how large icebergs, how small icebergs you really can observe with that, and when the icebergs are melting, if you are combining the melting prediction to the size of the iceberg, so how long it can be observed. So what is the lower part of the resolution, and is there anything what can be done in that? So the vector algebra method, so this is one way of approaching it. I was a little bit questioning what is your contribution with this method, because it's just stochastic analysis using vectors, but because sea ice has so many unknown features which can be just put in the random component, the stochastic approach is a very, very good for this. And the last chapter in the thesis, this is about the application to the Kara Sea for sea ice, and then the Barents Sea for this iceberg part. And I was very happy to see the results, and you had these ship channels and effect on the ice motions, and then the questions was in the air that do the ship traffic influence the ice dynamics in this basin or not? And the iceberg part, so this I consider was a very good success, apart from this question about the small icebergs, what can we do? So, thank you.
Thank you, Matti.
Thank you.
Ну, так как у профессора Лепаранта
As Professor Leparant does not have remarks in his review, and now I would like to give the floor to the member of Dissertational Council, Mr. Timokhov, Doctor of Physical and Mathematical Sciences of the Department of the Ocean Studies. Leonid Alexandrovich, please, you have the floor. Before announced drawbacks, I would like to express my own opinion concerning our candidate and his thesis. And the reading of the thesis, the acquaintance with this study impressed me a lot. The paper is written logically, in good language. The structure of work is very logic. Our candidate showed not only professionalism in his research, but also he showed wide knowledge of those works, of those directions, which are now published in these directions. And it seems to me that a very important moment when not only technical issues of the monitoring of ice drift were solved, but also in advance. Specific theoretical methods of analysis were formulated, and on the basis of preliminary theoretical analysis, he managed to raise the awareness of the data about ice drift. And the results of the experiments conforms with the theory, and it allows us to consider the obtained results truthful and reasoned. As for the drawbacks, they are not serious. They are serious, of course, but not so principal. In this paper, little attention is paid to the justification of the importance of obtaining the kinematic characteristics of ice on a sub-kilometer scale to improve the description of the rheology of ice in numerical models. The second point, Chapter 2 does not provide a sufficiently detailed justification for the choice in favor of the case descriptor against binary A case, and comparative assessments of the effectiveness of characteristic points are not represented. Number 3, some chapters are not connected to each other. For example, the second and the third chapter. I have already mentioned it and asked the question. The transition between these two chapters could be more logical and consistent. Number 4, Chapter 3 analyzes data up to 2006, which somewhat reduces the relevance of the findings on current trends in the ice drift velocities. The important modern direction in the use of oceanographic data, including the ice drift, is their assimilation into numerical models to improve the quality of numerical forecasts. This requires reliable quantitative estimates of the quality of the drift data, which was not explained by the author. And the last one, the dissertation does not always clearly indicate the personal contribution of the author. And my colleague has also remarked it. Despite these drawbacks, I think that our candidate Demchev, Denis Mikhailovich, deserves the degree of the candidate of the physical and mathematical sciences on specialty ocean studies. Leonid Alexandrovich, thank you very much. Please answer the remarks about the sub-kilometer scale. It is a very actual task for numerical modeling, as rheology is a large problem. The algorithm is able to restore, to retrieve such data, and it can become a separate investigation which can be done with the help of offered algorithm. In my work, and I analyzed on the scale of 1 kilometer, because it is always clear how to implement this data, and this algorithm allows us to conduct such researches. As for the second question, I have already answered to this question about case, the connection between the chapters, two chapters. I have already answered this question. And as for the relevance of the data In this work, it was not the task of the work, the whole range of the data. It was a demonstrative application of the vector and algebraic method of drifts. As for the assimilation of the data, which require a more detailed analysis about the movement of the ice, I agree with this remark, and it is very important for the tasks of assimilation, and my validation should be expanded without doubt, and it's a separate study. As for my own contribution, please, sorry I have not done it, and I tried to correct these mistakes in my presentation. Denis Mikhailovich, thank you very much. Ilya Alexandrovich, are you satisfied with the answers? The next review of the member of the dissertation board of Zimin Alexei Vadimovich, the Doctor of Geographical Sciences, the Professor of the Department of Ocean Studies of St. Petersburg State University. He is missing. He is in the expedition now, and let me read out his review. The justification of scientific provisions approved by scientific researchers. The conclusions are very successful and reflect the tasks, but the formulations of the provisions for the defense are disappointing. There are a lot of them, and they defines the limits of the research when considerable results were obtained. The section 2 and 2.3, tables 2.1 and 2.2 are given. Average and median distances between the starting points of the drift vectors are shown. They give estimates of distances up to 1/10 of a meter. Unfortunately, the paragraph does not indicate on what basis the resolution of satellite sensor data was processed. And are such distance estimates possible with the usual resolution of images of several tenths of meters per pixel? In section 3.2, figure 3.1 consists of many parts. It is difficult to read it. And page 56-58, the quality of the results of the research is very difficult to understand. Section 3.4, figure 3.2, consists of many parts. It is difficult to read. Part of the picture is not signed. Part of the notation is not clear. For example, what is the difference between gray and black arrows? And only from the text we can assume that what they mean. The perception of the references in the text of pages 63-66 and a discussion of the quality of the research results presented in the paragraph are difficult. In section 3.6, there is a phrase, the correlation of the orthogonal components for 0.87 lies on the border of the level of statistical significance. But for 0.89, there is no orthogonal correlations. The statement is controversial since estimates of the level of statistical significance in the work are not given. And in section 3.7, there is a phrase, the connection between the fields exists in 5 areas, figure 3.3, where the values of the new index exceeds 0.5. However, this figure shows the average monthly iced drift fields. In section 3.1.3, in figure 4, the repeatability histograms have a variable pitch, which makes it impossible to correctly compare their characteristics for different months. In section 4.2.3, the mesoscale ocean model block is presented in the general scheme of the developed technology for monitoring iceberg drift, but it is not mentioned further in the text, although it is one of the input blocks for the iceberg drift model. Given the wide range of issues raised in the thesis, a large number of conclusions are quite logical. However, in conclusion, it would be advisable to summing up all the diverse conclusions made to formulate a single conclusion on the work that meets the goal. And to conclude, by Zimin Alexey Vadimovich, he points out that our candidate deserves the scientific degree of the candidate of physical and mathematical sciences on specialty 250028 Ocean Studies. Please, Denis, answer the remarks of Zimin Alexey Vadimovich. As for the first question, as for the first remark about the precision of the data of such scales, we use the experimental approach. Unfortunately, I missed the description, but with the help of this approach, we obtained the precise data up to 0.10 meter. As for the picture 3231, I agree with the remark, and a better version of this figure is available in the print version of the relevant article, but it would be more useful to divide these pictures. I fully agree with this remark. As for the picture 3.4 and 3.2, I fully agree with it. As for section 3.6, when there is a phrase, the correlation of the orthogonal components for 0.87 lies on the border of the level of statistical significance. But for points 8 and 9, there is no orthogonal correlation. You know that I agree with this statement. Here we used in the article when the selection was more than 10 and the true correlation value of two scalar values is noticeably less than 1, the significance level of the statistical estimate of the correlation, not 0, according to the normalizing transformation of Fisher, is determined only by the size of the sample with the number of the degrees freedom n2. 1 degree of freedom per estimation of expectations, the second for estimation of linear regression coefficient. And it is stochastic and stipulated by orthogonal correlations is 0.15 on the virtue of statistical significance, and we refer to the works of Bolshev and Smirnov, Tables of Mathematical Statistics, 1968. Remark 5, concerning the phrase, the connection between the fields exists in 5 areas. The reference is to the wrong picture. It is a misprint. The letters near these pictures are mixed up. That's why you could not understand. As for the next question, I also agree that I am mistaken. I will correct this mistake about histogram. And as for the evaluations of middle the maximum ice drift velocities and average ice drift velocities which were observed in November, December, January, April, and June. The values of the model of the ice drift velocities for June are not given in the text of the work, although they were calculated. The next question, mesoscale ocean model. The model description is given in the article, but I missed it in my dissertation paper, and is for the conclusion of my work. I presented it in my thesis, and I agree with the remarks of Alexei Vadimovich. And the last review, it's my own review of the chairman of the Dissertational Council, Zakharchuk, Doctor of Geographical Sciences, Professor, acting head of the Department of the Ocean Studies of St. Petersburg State University. General remarks. And the page 4, the definition monitoring, would be better used the definition of monitoring accepted in Rosgidromet, Russian Weather Bureau. And if you use monitoring in the headline of your work, and that's why the tasks of your research should include the monitoring of ice drift and the thesis that the wide trans-Arctic current is directed from the Bering Strait to the Fram Strait is not quite correct. Page 15. The sources of this current are not only in the Bering Strait, but also in the seas of the Siberian shelf. And you used the Makazi method in comparison of other methods, but only winter conditions of the Arctic Ocean were taken into account, and such analysis would be more representative if our candidates presented the results of various types of analysis during seasonal changes and also in shallow seas of Siberian shelf, and in subsection 2.4.1, when comparing reference vectors with vectors obtained using various automatic algorithms, a methodical error was made. Theoretically, it is unacceptable to carry out mutual correlation analysis only with vector modules, since in this case the united connection between vector components. In paragraph 2.3, the author demonstrates the advantages of his proposed methods for calculating the ice drift, Makazi, compared to other methods. However, this comparison was carried out only for winter conditions of the Arctic Ocean. The general lack. The third chapter presents the results of applying the vector algebraic method for probabilistic analysis of time vector series. These results of the analysis of the data processing satellite images of ice for more than 25 years are given. The lack also there is no justification for the average monthly averaging of the divergence values of the ice drift field, picture 4.7 and 4.8, considering the applied focus of work related to solving navigation safety problems in ice conditions and the operation of engineering structures in that area. It would be very useful to provide examples, estimations of quasi-instantaneous divergences of the ice drift field once or twice a day. There are also comments upon the design of drawings. Fragments of figure 3.1, 3.2 are hard to read. Picture 4.10 has no geographical coordinates and dates. And figure 1.3, 1.11 and others, there are no geographical coordinates. That's all for my remarks. Please answer them. As for the monitoring, I fully agree with your remark and interpretation. I have nothing to add. And as for the sources of transarctic current, I also agree with you that the shelf of Chukchi and Eastern Siberian seas, they are the area of appearance of transarctic currents. As for the question connected with the algorithm for other seasonal conditions and other geographic areas, in particular continental slope, close to continental slope of the Arctic Ocean, I fully agree with you, and we have already discussed this question, and the analysis for other areas is required with different genesis of ice creation, ice formation, and I fully agree with you. As for mutual correlational analysis, I agree that it should not exist. I use vector algebra methods where there is no cut off this connection, but when we prepared the more technical publication for ice drift, we followed the widespread practice in Western literature, and they conduct this comparison in such a way, and to avoid some dubious, some secondary variants, we decided not to use something different. As for the comparison with the data of buoy monitoring, it is not correct to compare these methods to each other. We compare it with the data of interactive, manual, and expert analysis, which ice experts accomplished visually. It is independent data. And it is correlated with the precision data of buoys in those areas, about 100 or 300 meters, or 1 or 3 pixels, and papers also shows such results, the same results. It's very difficult to evaluate the precision data. As for the third chapter, the analysis of some points, not of the whole ensembles of the vector fields, I agree with your remark. And to imagine the picture in full extent, it is necessary to analyze the fields for correlation tensor. As for the middle month scales of the average ice drift, I agree here, and about quasi-instant figures, I forgot to give such an examples, but on the whole I agree that methodological basis was not studied thoroughly for the averaging of this data. And as for the remark concerning the pictures, I fully agree with you, and about geographical coordinates, sorry that I didn't notice it before. That's all. Denis Mikhailovich, thank you very much. I am satisfied with your answers. Dear colleagues, according to our agenda, the speeches of those who are sitting in the hall, non-bowed members, maybe any comments? I would like to say concerning the dissertation, I got acquainted with this thesis in 2018. It was improved and the name was changed. Of course, there are some drawbacks, and it is a typical thing of any thesis, and for literary sources and a considerable part of the literary sources, they are in English. Detailed analysis, these literary sources is very impressive, and it is very pleasant to see. This thesis is unusual because often we see the images in optical, infrared scale, but here another method is used. Some images are used in the analysis. That's why usually here an interesting method was applied by Denis Mikhailovich with the help of radar censoring. Speckles noise presents, and we should avoid it. When we speak about digital processing of the information, there is little physics, and if we take a classical work on digital informational systems, I was surprised when I found out the second law of Newton. And in this study there is a lot of physics, digital processing. It is combined with digital processing of the image, and of course it deserves positive appreciation, estimation. I like the report of the candidates. I liked the report of Denis Mikhailovich, his answers to the question, and I'm sure that all the efforts of our candidates
в Институте Арктики и Антарктики
are not in vain, and the practical significance of the work is obvious, and our candidate deserves the candidate degree in physical and mathematical sciences on the specialty oceanology. The matter is that we work with Denis in practical sphere, not only in scientific sphere, and I would like to highlight then within these few years, Denis created a team. He made a practical research. Konstantin Smirnov is present here. They made together a brilliant project devoted to these researches on ice drifts in Ob Bay, and this portal is operating now. It is a very demanded and popular portal. His thesis, it is a very long work, and today it is the stage for the finishing of the scientific part, and the guys implement the theory into practice. And I am a practical person. For me it is very important that they defend their thesis every day, but in practice, you see. Alex, thank you very much. Any other volunteers Vladimir Alexandrovich Volkov, Nansen Center, the head of the group of applied meteorological and oceanal studies in the center, Denis Mikhailovich, also works in Nansen Center, and he came to us right after the graduation from Hydrometeorological University. He is has been cooperating with our center almost 15 years. Our center is project oriented, and we cooperate with young researchers, with young workers, and our idea is to come from the need to practice, and we implemented international projects, mostly Russian projects, and Denis Mikhailovich became a developer of the methods on the basis of satellite data. The profile of our center is the realization and implementation of satellite data, and thus this topic appeared and developed, and our candidate he's broad-minded in scientific terms. He has been an analytical worker in our center. He is responsible for within the frames of the big project by the order of huge ecological organization concerning the exploration of the Ochota Sea. Not only this sea and other northern Arctic seas are taken into account, and here Denis Mikhailovich showed himself as specialist, especially in terms of the digital technologies, the application of computer technologies. He has profound knowledges in space and satellite monitoring. Denis takes part in the preparation of, in training of young specialists. Bachelor and master's students prepare their dissertational papers in our center, and Denis takes active part in consulting activity, and the methods developed by him are in great demand at our customers. Strictly speaking, to cut it short, Denis Mikhailovich, he is a young from young specialists. He now he has become a very experienced specialist, and he deserves without doubt the degree of the candidate of physical and mathematical sciences, and I hope that he will cooperate with our institute in the future. Any other volunteers who want to have the floor? And now the floor is given, should be given to scientific supervisor, but unfortunately scientific supervisor is ill, and I have to read out his review. The scientific supervisor, Doctor of Physical and Mathematical Sciences, Alexander Petrovich Makstas, the chief scientific worker of the Institute of Arctics and Antarctics. For the period of the working with the thesis, Denis Mikhailovich Demchev showed a great active interest to the satellites of ocean sciences, numeric modeling, data processing. He is a participant of many international practical conferences. He is a very experienced specialist in this area. He is able to be an independent scientific worker. Denis Mikhailovich conducted a huge research with the aim to evaluate the efficiency of the methods of the monitoring of sea ice drift. In Russian literature, these questions are poorly studied. In this context, he
Решение и проведенное
the solution, and he conducted the complex evaluation of the monitoring methods of sea ice and icebergs drifts are very successful, and they should be further studied. And the work of Demchev Denis is of high implementational level. The materials of the thesis were tested and implemented into the work of the oil extracting companies Yamal-SPG, Rosneft, and Gazprom, and many others. During his research, Denis had the opportunity to receive knowledge in radar sensoring, ocean studies, and he successfully passed candidate exams and so on. I'm sure that the thesis of Demchev is a qualified, completed scientific research which makes a new and considerable contribution into the increase of quality of ice monitoring in the Arctic, and the thesis conforms with the High Attestation Committee requirements and can be submitted for the defense, and his author, Mr. Demchev, deserves the scientific degree of the candidate of mathematical and physical scientists. According to our agenda, I would like to consult with the members of the Dissertational Council. Do we need to have a 5 minutes break? The discussion by members of the Council of the issues of awarding a scientific degree, or we may skip this 5 minutes break. And please, every board member, give your conclusions concerning our candidate. Tatiana Vasilevna, please, the floor is yours. We heard a brilliant report and presentation, and the work itself provides a good and positive impression. Of course, in every work, drawbacks can be found in terms of pictures, structure, but I could not find any remarks which would be of principal character, which could influence my intention to support this work. And I think that the thesis of Demchev Denis Mikhailovich conforms with the requirements of St. Petersburg State University, and Denis Mikhailovich deserves the degree of the candidate of Physical and Mathematical Sciences on specialty 250028 Ocean Studies. Tatiana Vasilyevna, thank you very much. Professor Matila Piranta, the turn is yours. Please be brief as possible.
Yes, thank you. It was my pleasure to read the thesis and hear the presentation and discussion what has been done today. And I'm been very satisfied with the results. And I think I mentioned in my review that the main thing is that Denis Demchev has developed a new method for extracting kinematics from the SAR data, and which has advantages over the previous work, and so this is an important step in the understanding of the sea ice dynamics. And then he has applied this method for statistical analysis of the data with his one method, but first of all use the method for Karachi sea ice and the Barents Sea icebergs, with very, very good results. So my experience in doctoral dissertations is mainly from Finland, Scandinavian countries. I've been taking part in about 30 committees in my career, and certainly the value of this thesis is, the level of this thesis is well above the mean thesis what I see in Scandinavian countries, and I recommend this acceptance. Thank you.
Спасибо, профессор Лаперанта. Слово...
Professor Laperanta, thank you very much. And Mr. Timokhov, please, your word. I have already mentioned that I was greatly impressed by the thesis. It produced a positive impression for me. It is accomplished at high scientific level, professional level, and the candidate our candidate, when he reported about his results and answered questions, he showed great professionalism. He is an educated and literary person. It seems to me that he is already a scientific worker of high level, and that's why I think that Demchev deserves the scientific degree of the candidate of physical and mathematical sciences on this specialty, and it is a good beginning to think on the continuation of the work in the direction of doctoral degree, doctoral study. And as for me, some words about the candidate. I liked the work of Denis Mikhailovich. It is an actual, it is relevant because it has significant apply. It has a significant application. Denis Mikhailovich developed a range of new methods and approaches for the processing and analyzing of satellite radar information, and he prepared a good report. He answered the questions very directly, and he deserves the degree of the candidate on physical and mathematical sciences. Dear colleagues, and I raise the question of awarding an academic degree to an open roll call. I remind you that the decision of the Dissertation Council of the issue of the awarding the degree is considered positive if more than half of it voted for, but not less than 3 members of the Dissertational Council who participated in the meeting, in accordance with paragraph 23 of the procedure for awarding academic degrees at St. Petersburg State University, appendix number 1 to the order. Board member Tatiana Vasilyevna Belonenko, your opinion. I am for. Thank you. Board member Matthew Hanin Laperanta, your opinion.
Thank you.
Board member Timokhov Leonid Alexandrovich, I am for the academic degree of the candidate on physical and mathematical sciences, and me, Zakharchuk, I am for the degree which should be awarded to Denis Mikhailovich, the degree of candidate on physical and mathematical sciences 250028 Ocean Studies. Dear colleagues, thus I declare that out of 4 members of the Council All 4 members of the meeting voted for. There were no against and abstained people. Decision on awarding the academic degree of the candidate of Physical and Mathematical Sciences on specialty 230028 is accepted. In conclusion, the final words of the candidates. Denis Mikhailovich, the floor is yours. Thank you very much for such high appreciation of my work. Distinguished members of the dissertation board, thank you very much. It will give me a stimulus to work in the future. All the guests, thank you very much. Those who had the floor today, those who supported me, thank you very much. I want to express my gratitude to my parents. And I want to express my gratitude to 2 centers, the Center of Arctics and Antarctics, and Northern International Environmental Center. They helped me to write this thesis and conduct this study. I'm not going to list everyone who supported me. I want to again express my gratitude to everyone who supported and helped me. Denis Mikhailovich, thank you very much. Thus, our agenda is over. The meeting is declared closed. Thank you all for participation. Please switch off the live broadcast of the meeting. Thank you.